NASA has hit the jackpot this time. Okay, the Holy Grail is to find an Earth-like twin in outer space.
One step closer to answering the age-old question, are we alone in the universe? NASA announced the discovery of 7 Earth-sized planets around a star about 40 light years away from Earth. That translates to 235 trillion miles.
NASA's James Webb Telescope has captured the clearest image yet of what appear to be glowing alien cities on Proxima B. The rocky planet, orbiting a star just over 4 light-years away, has astonished scientists with its strange lights. This discovery could finally answer one of humanity's oldest questions. Is there something even more surprising waiting for us in this distant world? Let us take a closer look and uncover the reason why so many NASA employees are fleeing the country. The struggle for survival on a distant world. The discovery of Proxima B sent ripples through the scientific community, hailed as a potential jackpot. While it lies in the habitable zone, a region where liquid water might exist, its conditions are far from inviting. The planet's tidal locking means one side faces constant fiery heat, while the other is frozen in eternal night. These extremes could obliterate the possibility of life as we know it, but a slim, temperate band may exist between the light and dark. Here, conditions might support liquid water and possibly life. However, life on Proxima B, if it exists, would likely be unlike anything we've ever encountered. Before we delve into this, it's clear that these glowing lights may point to something far more extraordinary than anyone anticipated, and this revelation is only the beginning. Proxima B's proximity to its star subjects it to intense radiation storms. These flares could strip away any atmosphere or make the surface uninhabitable. Yet life has proven its resilience on Earth, thriving in hostile environments such as deep-sea vents and radioactive zones. Could similar adaptations occur here? Could life feed on radiation or find refuge deep beneath the surface, shielded from the star's violent outbursts? These are questions the James Webb Space Telescope aims to answer. The James Webb Telescope, an engineering marvel, has revolutionized our ability to observe distant worlds. Its capabilities surpass those of the Hubble telescope by a factor of 100, providing unprecedented clarity. By analyzing the atmosphere of this exoplanet, Webb could detect signs of water, oxygen, or even unusual chemical compounds that hint at biological activity. Yet even with these tools, the reality remains daunting. This world may be barren, offering more questions than answers. It orbits a red dwarf star, the most common type of star in our galaxy. While these stars are small and dim compared to our sun, they burn their fuel at an astonishingly slow rate, lasting up to 100 billion years. This longevity gives planets ample time to evolve, but red dwarfs also have a dark side. Their unpredictable flares can devastate nearby planets, potentially erasing any chance of life. For this planet, this means constant exposure to a harsh environment, challenging any potential for habitability. Despite these challenges, the abundance of red dwarfs in the galaxy makes them critical to understanding planetary systems. They account for nearly 75% of the stars in the Milky Way, suggesting that planets like this one may be more common than previously thought. If life can survive the trials of a red dwarf system, it could thrive elsewhere, opening up new possibilities in the search for life beyond Earth. The ethical implications of exploring such worlds are profound. Sending probes or spacecraft to pristine planets risks contamination. Introducing Earth's microbes to an alien environment could irreversibly alter its ecosystem, potentially destroying what makes it unique. Humanity's history of exploration on Earth has often led to unintended consequences, from invasive species to ecological collapse. Could we make the same mistakes on a cosmic scale? These questions demand careful consideration as our technology brings interstellar exploration within reach. Even if this planet harbors no life, its study offers invaluable lessons about our own planet. Earth's finely tuned balance of conditions is rare, perhaps unique. The harsh extremes of this exoplanet highlight how fragile and precious our home truly is. As climate change, pollution, and deforestation threaten Earth's stability, this distant world serves as a stark reminder. There is no planet B. Protecting Earth must remain our top priority, even as we dream of the stars. The search for life on this planet has sparked deeper thoughts about what this means for the future of humanity. the search for life among the stars. The search for life here also forces us to confront the Fermi paradox. If intelligent life is common, why haven't we found it? Some speculate that advanced civilizations may avoid contact or self-destruct before achieving interstellar communication. Others suggest that we simply haven't looked hard enough or in the right way. This planet offers an opportunity to refine our search, focusing on the subtle signs of life that might exist under vastly different conditions. Its exploration is not without risks. Attempting to colonize or exploit such a world could bring unforeseen consequences. Even a seemingly small action, like landing a probe, could disrupt its environment. History has shown us the cost of careless exploration on Earth, and the stakes are even higher on a cosmic scale. Yet the desire to explore is deeply human, driven by curiosity and the hope of discovery. The planet's conditions may seem inhospitable, but they challenge us to rethink the possibilities of life. Could organisms evolve to harness radiation or thrive in extreme climates? Could life flourish in ways that defy our understanding of biology? These questions push the boundaries of science, inspiring new research and technologies. Each discovery brings us closer to answering the fundamental question: are we alone in the universe? The potential for life here is both thrilling and sobering. It forces us to consider the implications of finding life beyond Earth. What would it mean for our understanding of biology, evolution, and our place in the cosmos? How would humanity react to the knowledge that we are not alone? These questions are as profound as they are unsettling, challenging our assumptions about life and the universe. As we prepare for the possibility of interstellar exploration, ethical guidelines must evolve to address the unique challenges of venturing beyond our solar system. The balance between discovery and preservation is delicate. This planet highlights the need for caution and respect in our approach to new worlds. The choices we make today will shape the legacy we leave for future generations. This distant exoplanet also underscores the importance of investing in Earth's future. While exploring other planets is exciting, it should not distract from the urgent need to address the challenges facing our own world. Climate change, biodiversity loss, and resource depletion threaten Earth's ability to sustain life. Protecting our planet is not just a moral imperative, it is a practical necessity. The lessons learned here can inform our efforts to create a sustainable future on Earth. The appeal of this world lies not only in its potential for discovery, but also in the questions it raises. As we look to the stars, we must also look inward, reflecting on what it means to be stewards of our planet and explorers of the universe. This exoplanet is a symbol of both possibility and responsibility, reminding us that the search for life beyond Earth is as much about understanding ourselves as it is about the cosmos. It may or may not harbor life, but its existence expands our understanding of what is possible. It challenges us to think bigger, to dream of new horizons, and to confront the ethical dilemmas of exploration. As the James Webb Space Telescope continues its mission, this planet remains a focal point of curiosity and wonder. What we find there could reshape our understanding of the universe and our place within it. The story of this exoplanet is far from over. Each discovery brings new questions, fueling the drive to explore further. Whether it is a barren rock or a cradle of life, it holds a mirror to humanity's deepest hopes and fears. It reminds us that the universe is vast, and our place within it is both humble and extraordinary. As we reach for the stars, let us do so with care, curiosity, and a sense of shared purpose, knowing that the answers we seek may redefine everything we know. From watching the stars to walking on the moon, humans have always explored, and each step forward has revealed even more, reaching beyond the atmosphere. Humans have always been curious about the stars. For thousands of years, we gazed at the night sky, guessing what might be out there. It wasn't until the 20th century that we found a way to actually leave Earth and explore space. Rockets, once just weapons or experimental projects, became the tools to break through our atmosphere and head into the unknown. The Soviet Union kicked things off in 1957 with the launch of Sputnik 1. This little metal ball with antennas became the first human-made satellite to orbit Earth. It might not seem like much today, but back then, it was a big deal. It showed that we could send something into space and keep it up there. Then in 1961, Yuri Gagarin, a Soviet cosmonaut, took things to the next level. He became the first person to travel into space, completing an orbit around Earth in just 108 minutes. His flight wasn't just about showing off. It proved that humans could survive in space, even if only for a short while. Not wanting to be left behind, the United States entered the race. In the same year, 1961, Alan Shepard became the first American in space with a short suborbital flight lasting just 15 minutes. A year later, John Glenn orbited Earth 3 times, making history for the U.S. These missions were part of NASA's Mercury program, which was designed to test how humans could handle space travel. The competition between the U.S. and the Soviet Union was intense, and each side kept trying to outdo the other. In 1963, the Soviets sent Valentina Tereshkova into space, making her the first woman to leave Earth. She orbited the planet 48 times over 3 days, proving that women could handle the harsh conditions of space just as well as men. This period, known as the space race, saw rapid advancements in technology and daring missions that pushed the limits of what was possible. Then came the moment that changed everything: the moon landing. In 1969, NASA's Apollo 11 mission landed Neil Armstrong and Buzz Aldrin on the lunar surface. Armstrong's first steps were broadcast live to millions of people. In his words, "That's one small step for man, one giant leap for mankind," became legendary. This achievement showed that humans could not only reach another celestial body, but also return safely. The moon landing remains one of the most iconic moments in human history. After the Apollo missions, the focus shifted to staying in space for longer periods. In 1971, the Soviet Union launched Salyut 1, the first space station, where cosmonauts could live and work for weeks at a time. NASA followed with Skylab in 1973, hosting astronauts for missions that lasted up to 84 days. These early space stations were stepping stones, teaching us how to live in space and paving the way for future projects. In the 1980s, NASA's Space Shuttle program brought a new era of space travel. These reusable spacecraft could carry astronauts, cargo, and even satellites into orbit, and then return to Earth for reuse. The shuttles performed all kinds of missions, from fixing the Hubble Space Telescope to helping build the International Space Station. However, the program wasn't without tragedy. The Challenger disaster in 1986 and the Columbia disaster in 2003 were stark reminders of the dangers of space travel, claiming the lives of 14 astronauts. The ISS, which became operational in the early 2000s, is a shining example of international cooperation. Built and maintained by the US, Russia, Europe, Japan, and Canada, the station serves as a laboratory for cutting-edge science. Astronauts conduct experiments in microgravity, studying everything from human biology to the behavior of materials. The ISS also tests technologies that will be essential for future missions to the Moon and Mars. In recent years, private companies have entered the space game, bringing fresh energy and innovation. SpaceX, founded by Elon Musk, has revolutionized the industry with its Falcon rockets and Dragon spacecraft. In 2020, SpaceX's Crew Dragon became the first privately developed spacecraft to carry astronauts to the ISS. This marked a new chapter in space exploration, showing that private companies could do what was once the domain of government agencies. Other companies like Blue Origin and Virgin Galactic are working on making space accessible to more people. They're developing spacecraft for suborbital flights, allowing private citizens to experience a few minutes of weightlessness and see Earth from above. While still expensive, these developments hint at a future where space tourism could become more common. Looking ahead, the focus is on returning to the Moon and eventually reaching Mars. NASA's Artemis program aims to land the first woman and the next man on the lunar surface, with plans to establish a sustainable presence there. The Moon will serve as a testing ground for technologies and strategies needed for Mars exploration. Meanwhile, private companies in other countries are also eyeing the red planet, each with their own plans for sending humans to our neighboring world. Space exploration has also brought countless benefits to life on Earth. Satellites have transformed how we communicate, navigate, and predict the weather. Research conducted in space has led to medical breakthroughs, new materials, and technologies that we use every day. From GPS to advancements in cancer treatment, the ripple effects of space exploration are felt far and wide. The path into space is far from over. Humans have always been driven by curiosity and the desire to explore. As we look to the future, the possibilities seem endless. Whether it's building colonies on Mars or finding ways to travel to distant stars, one thing is clear: we're just getting started. Every new discovery about the universe shows how much more there is to learn and understand. How it all began. The universe is a vast, perplexing realm brimming with unanswered questions that push the limits of what we think we know. Let's start with the biggest question: how it all began. Scientists often talk about the Big Bang, an event billions of years ago that supposedly kick-started everything. But here's the catch: nobody knows what caused it or what was around before it happened. Was there an endless void or something even more unimaginable? Then comes the issue of where it's all heading. Some believe the universe might keep expanding until it's a cold, lifeless expanse. Others think it could collapse back into a fiery crunch. Either way, the fate of the cosmos hangs in a balance we barely understand. Next, we encounter the shadowy entities known as dark matter and dark energy. Together, these invisible forces supposedly make up most of the universe. Dark energy, for example, seems to be driving galaxies farther and farther apart, accelerating the universe's expansion. But what exactly is it? Is it a force, a property of space, or something we haven't even imagined yet? Dark matter isn't any less strange. It's thought to hold galaxies together, yet we've never seen it or directly detected it. What if our understanding of it is completely wrong? The idea of multiple universes, or the multiverse, adds another layer of mind-bending possibilities. Some theories suggest our universe might be one of countless others, each with its own unique laws of physics. While intriguing, it's also frustrating. There's currently no way to prove or disprove this idea. Are we just a small piece of an incomprehensible cosmic mosaic? Time, the invisible thread that holds our lives together, is another topic scientists grapple with. We experience it as a steady march forward, but physics suggests it could be much more fluid. Could time travel ever be possible? If so, how would it work, and what consequences might it have? The nature of time, its beginning, end, and flexibility, remains a tantalizing question. Then there's the possibility of life beyond Earth. The sheer size of the universe makes it hard to believe we're alone. With billions of galaxies, each containing billions of stars and planets, the odds seem to favor the existence of extraterrestrial life. Yet despite decades of searching, we've found no definitive proof. Are we looking in the wrong places? Or is life elsewhere fundamentally different from what we expect? Black holes are equally baffling. These regions of space, where gravity is so intense that not even light can escape, challenge our understanding of physics. Recent breakthroughs like the first image of a black hole have brought us closer to understanding them. Still, questions linger. What happens to matter that falls in? Could black holes connect different parts of the universe or even different universes? On a more tangible level, there's the composition of the universe itself. While we've identified many elements and particles, there are gaps in our understanding. For instance, why is there less lithium in the universe than our models predict? Discrepancies like these hint that our theories might need revising. Galaxy formation also remains an area full of unknowns. While we have general models, the specifics are murky. How does dark matter influence the birth of galaxies? Why do they take on such diverse shapes and sizes? The forces shaping these colossal structures are still not fully understood. Looking further back, the early universe presents its own questions. Observations of the cosmic microwave background radiation offer a glimpse of the universe in its infancy. But how did the first stars and galaxies emerge from this primordial soup? The details of this cosmic dawn remain elusive. Gravity, the force that governs the motion of stars, planets, and galaxies, has its own questions. While we understand its effects on large scales, its behavior at microscopic levels is less clear. Could solving this question lead to a deeper understanding of the universe's fundamental forces? Some theories propose the existence of extra dimensions beyond the three we experience. If true, these dimensions could help explain some of the universe's fundamental properties. However, we have yet to find any experimental evidence to support their existence. Neutrinos, tiny particles that rarely interact with matter, present another challenge. These particles are incredibly abundant, yet their properties remain largely unknown. Understanding neutrinos could unlock new insights into the universe's workings. Quantum mechanics, the study of the smallest particles in the universe, is another field filled with questions. While it explains many phenomena, it also raises paradoxes. Why do particles behave like waves under certain conditions? And how does the act of observing something change its behavior? Cosmic rays, high-energy particles from space, are another topic of intrigue. While we know some originate from the sun, others come from sources we haven't identified. What events produce these incredibly powerful particles? The quest for a unified theory of physics aims to combine our understanding of the universe's forces into a single framework. While promising, this goal has remained elusive. Could such a theory answer many of the universe's other unanswered questions? Finally, the large-scale structure of the universe, the way galaxies and clusters form web-like patterns, presents its own questions. What caused these structures to form? And what can they tell us about the universe's past and future? At the heart of black holes lies the singularity, a point where our current understanding of physics breaks down. What happens in these extreme conditions? Could studying singularities reveal new laws of nature? The universe's unanswered questions remind us of how much we have yet to learn. Each discovery leads to new questions, pushing the boundaries of what we think is possible. The cosmos, with all its complexity, challenges us to keep asking, exploring, and dreaming. As we gaze at the stars, we are reminded that the path to understanding the universe has only just begun. The telescope that changed everything. The James Webb Space Telescope, humanity's most advanced eye in the sky, was supposed to clear things up. Instead, it's made the picture messier. Its ultra-precise measurements have confirmed the conflicting data, leaving scientists scratching their heads. This isn't a minor error or a glitch in calculations. It's forcing researchers to face the possibility that something fundamental is missing from our understanding of how the universe works. Imagine building a jigsaw puzzle for years, only to realize that not only are some pieces from a different set, but you've been working on it upside down. That's where science finds itself right now. Before we delve into this, it's becoming clear that the universe might be hiding something far stranger than anyone ever predicted. And this won't be the only revelation to leave you speechless. One of the biggest questions being re-examined is the concept of dark matter. For years, dark matter has been the go-to explanation for why galaxies behave the way they do. It's an invisible glue that holds everything together. Without it, nothing in our cosmic models makes sense. But now, data from JWST is suggesting that dark matter might not exist as we've imagined it. If that's true, then what's keeping galaxies from flying apart? Are we missing an entire piece of the cosmic problem, or has the whole game changed? As if that weren't enough, quantum physics adds even more chaos to the mix. On the smallest scales, particles behave in ways that defy logic, and nothing seems certain. When this unpredictability collides with the vast complexities of an ever-expanding universe, it's no wonder scientists are struggling to make sense of it all. But here's the thing, this confusion is a sign of progress. Science thrives on challenges. When things don't add up, it's often a precursor to groundbreaking discoveries. It's as if the universe is daring us to look deeper, to question more, and to push the boundaries of what we think we know. For years, scientists believed the universe expanded uniformly in every direction, a concept called isotropy. But JWST has revealed anomalies in this theory. Some regions appear to be expanding faster than others, while certain galaxies exhibit behaviors that don't match the norm. Think of the universe as a lava lamp, with blobs of matter moving at different speeds, colliding and shifting unpredictably. If this patchwork reality holds true, it's a complete departure from the idea of a smooth, consistent cosmos. And then there's the idea of the multiverse. Once dismissed as science fiction, it's now gaining credibility. The strange data coming from JWST could hint at interactions between our universe and others. Imagine our cosmos bumping up against parallel dimensions, influencing each other in ways we're only beginning to glimpse. If true, this would radically alter how we see our place in the grand scheme of things. Another shocker. Galaxies that shouldn't exist are popping up in JWST's observations. These galaxies seem far too developed for their age, forming almost immediately after the Big Bang. Current models can't explain how they grew so quickly. It's as if the universe hit the fast-forward button and we're left scrambling to figure out how. Gravitational lensing, a phenomenon where light bends around massive objects, has also revealed discrepancies. This was supposed to be one of the strongest pieces of evidence for dark matter, but now it's showing patterns that don't align with our expectations. It's like using a map to navigate only to find the roads have moved. As dark matter ideas fall apart and gravity's role is questioned, new findings show the universe might act in ways we still don't fully understand. The gaps that challenge the Big Bang. Void spaces in the universe, vast areas with little to no matter, pose another problem. These gaps challenge the idea of a uniform Big Bang explosion. If the universe was supposed to spread out evenly, why do these giant empty regions exist? JWST's detailed observations of these voids only deepen the problem, suggesting that matter might be distributed in ways we've never considered. Some scientists are even questioning whether our understanding of gravity itself needs an overhaul. If dark matter doesn't exist, then perhaps gravity behaves differently on large scales than we've assumed. All of this points to a universe that is far stranger and more complex than we ever imagined. Theories that once seemed solid now feel shaky. Constants like the speed of light or the force of gravity, once considered unchanging, might not be so constant after all. Tiny shifts in these numbers over billions of years could have enormous implications. If they've been evolving, it's like discovering the cosmic rulebook has been rewritten while we weren't looking. Quasars, the incredibly bright objects powered by black holes, are adding to the intrigue. By studying the light they emit, scientists have found hints that fundamental constants might have been different in the distant past. This isn't definitive, but it's enough to make researchers pause and rethink. Are we seeing signs of a universe that changes its rules over time? If so, how do we even begin to comprehend such a dynamic cosmos? The idea of evolving physical laws could also provide clues to some of the biggest questions in physics. Why did the universe start expanding so rapidly after the Big Bang? What drives the strange force known as dark energy? If the constants governing the universe aren't fixed, they could help explain these phenomena. It's a mind-bending possibility that challenges everything we've built our understanding on. Advances in technology are helping scientists tackle these questions. Instruments like JWST and super-precise measuring tools are giving us data we could only dream of a few decades ago. Each new observation is like a piece of a problem, sometimes fitting neatly, other times forcing us to rethink the entire picture. The search for answers is slow, deliberate, and often frustrating, but that's the nature of science. It's not about quick fixes, it's about building a deeper understanding over time. As we push the boundaries of what we know, we're also confronting the limits of our imagination. The possibility of evolving constants, multiverses, and shifting cosmic laws is both thrilling and daunting. It's a reminder that the universe is not a static machine, but a dynamic, ever-changing entity. Every discovery forces us to ask new questions, to challenge old assumptions, and to look at the cosmos with fresh eyes. These challenges are what makes science so exciting. The universe isn't just a collection of stars and galaxies. It's a vast, complex problem waiting to be understood. And while we may never have all the answers, the path of discovery is what truly matters. With each step forward, we're not just learning about the cosmos, we're learning about ourselves and our place in this ever-expanding universe. New breakthroughs in science and technology during 2024 have changed how we see the world and ourselves in surprising ways. Breakthroughs that will shape tomorrow. The year 2024 wasn't just another lap around the sun for science, it was a time of bold strides and jaw-dropping discoveries. Across fields like medicine, space, and environmental science, humanity's curiosity led to breakthroughs that could reshape our future. Forget the mundane. These are the stories that will make you wonder about the limits of human ingenuity. From battling deadly bacteria to uncovering alien worlds. Here's what stood out this year. Let's start with one of the scariest foes humanity faces, antibiotic-resistant bacteria. Scientists came up with new antibiotics that specifically target a protein called LPXH. This breakthrough showed promise in treating infections in mice that had been resistant to most treatments. If this works for humans, it could save millions of lives. The antibiotic crisis isn't over, but this development offers a ray of hope. Meanwhile, over in the realm of space, China's Chang'e 6 mission went where few have dared, the far side of the moon. The spacecraft not only landed, but also brought back samples of lunar soil. This historic event offered us new data about the moon's structure and history, helping us understand the celestial body's past like never before. Could these discoveries one day help us build bases on the moon? Astronomers, always on the lookout for the extraordinary, found the slowest spinning neutron star ever recorded. Called ASCAP J 1935 plus 2148, this star takes a mind-boggling 54 minutes to complete a single spin. This discovery has scientists scratching their heads as it challenges existing theories about how neutron stars form and evolve. The universe keeps throwing surprises at us. In the tech world, artificial intelligence showed off some serious skills in 2024. AI models like AlphaFold reached new levels of accuracy in predicting protein structures. Why does this matter? Because proteins are the building blocks of life, and understanding their shapes can speed up substance discovery and revolutionize medicine. What's next? AI-powered cures for diseases we once thought incurable? Speaking of building blocks, environmental scientists developed a battery made of carbon fiber composite. This material, as stiff as aluminum but incredibly energy dense, could make electric vehicles lighter and more efficient. Imagine driving a car that charges faster and goes further, all thanks to this new tech. The potential applications don't stop at cars. Think portable electronics, power grids, and beyond. On the subject of the brain, neuroscience unveiled a new circuit in mice that controls inflammatory reactions. This discovery sheds light on how the nervous and immune systems communicate. Understanding this link could lead to groundbreaking treatments for conditions like arthritis or autoimmune diseases. It's a tiny circuit with massive implications. Quantum physics also had its moment in the spotlight. Scientists created the smallest quantum light detector ever, fitting it onto a silicon chip. This innovation brings us closer to integrating quantum tech with everyday electronics. Secure communication and faster computing might not be science fiction much longer. The James Webb Space Telescope continued its streak of jaw-dropping discoveries by measuring the core mass of an exoplanet called WASP-107b. With its unusually low methane levels and massive core, this planet's data challenges what we know about how planets form. What other surprises do distant worlds hold? In climate science, researchers delivered a chilling warning. Even with current policies to limit global warming, tipping points like the collapse of the Atlantic meridional overturning current are dangerously close. This isn't just about warmer summers, it's about global systems failing. The need for urgent action couldn't be more clear. Biology hit a new milestone when scientists mapped every single nerve cell and connection in a fruit fly's brain. That's 139,255 neurons and millions of synapses. This atlas of the fruit fly brain offers insights into how more complex brains work, including ours. It's a small step for flies, a giant leap for neuroscience. Cancer research had a breakthrough with an mRNA-based melanoma vaccine entering final stage trials. This personalized treatment could train the immune system to target specific cancer cells. If successful, it's a game changer for how we fight cancer. In the search for other Earths, astronomers discovered an Earth-sized exoplanet, Gliese 12b, just 40 light-years away. With conditions that might support life, this find adds to the growing list of potentially habitable worlds. Are we getting closer to finding a cosmic neighbor? Materials science delivered a sparkle of its own. Researchers figured out how to grow synthetic diamonds at atmospheric pressure in just 2.5 hours. This method doesn't require seed crystals and could revolutionize diamond production for industrial use. Cheaper, greener diamonds might soon be a reality. The European Space Agency's Euclid telescope gave us stunning images of star-forming regions like Messier 78. These pictures reveal the early stages of how stars and galaxies come to be. Each image is like looking back in time. Conservation efforts brought good news with the Iberian lynx population bouncing back. Once critically endangered, this species has moved up to vulnerable status thanks to dedicated efforts. It's proof that targeted conservation can work. Aging, it turns out, isn't a slow, steady process. Scientists discovered it accelerates in bursts, especially around the ages of 44 and 60. This finding could lead to new ways to promote healthy aging and extend lifespans. Archaeology rewrote history with artifacts from Parsons Island, Maryland, suggesting humans reached North America 22,000 years ago. That's thousands of years earlier than previously thought, shaking up what we know about human migration. On the lighter side, researchers developed an AI sarcasm detector with 75% accuracy. While this might seem amusing, it has real-world uses in improving human-computer interactions. Mars made headlines again with the confirmation of liquid water 6 to 9 miles below its surface. This discovery could change how we explore the red planet and search for life there. The James Webb Space Telescope also spotted the most distant galaxy ever recorded. Jada's GSZ 14 Cero. Formed only 290 million years after the Big Bang, it offers clues about the early universe. In an eco-friendly twist, scientists use cheese-making waste to extract gold from electronic waste. This method could make recycling precious metals more sustainable and cost-effective. A new class of life was found in the human digestive system. Called obelisks, these tiny entities could change how we understand the microbiome and its impact on health. Gravitational waves got a boost with the approval of the Laser Interferometer Space Antenna mission. This project will help us study events like black hole mergers in more detail. From the depths of space to the intricacies of the human body, 2024 proved that science never stands still. Each discovery brings us closer to answering the big questions about life, the universe, and everything in between. From early rockets to dreams of reaching Mars, the story of space exploration is one of amazing progress and endless curiosity. The rise of space exploration. Humans have always been fascinated by the stars. There's just something about the vastness of the night sky that stirs up curiosity and dreams. For centuries, people looked up, imagined other worlds, and wondered what it would take to reach them. Fast forward to the 20th century, and finally, the tools to make those dreams a reality began to take shape. Rockets, once weapons of war, turned into keys to the universe. In the late 1950s, the Soviet Union made history with Sputnik 1, the first human-made satellite. That little metal sphere about the size of a beach ball zipped around Earth and sent back a simple radio signal. It wasn't much, but it was enough to kickstart the space race. 4 years later, Yuri Gagarin, a Soviet cosmonaut, strapped himself into a rocket and became the first person to orbit Earth. Can you imagine the sheer nerve it took to be the first human launched into the unknown? He made it back safely after 108 minutes in space, proving humans could handle the harshness of the cosmos, at least for a short while. Not to be outdone, the United States threw its hat into the ring. In 1961, Alan Shepard took a 15-minute trip to the edge of space, becoming the first American to leave Earth. It wasn't in orbit, but it was enough to show the U.S. was serious. A year later, John Glenn went even further, circling the globe 3 times and giving the nation a much-needed boost of pride. This back-and-forth competition between the U.S. and the Soviets wasn't just about space. It was about showing off power, technology, and influence. By the mid-60s, things really started heating up. In 1963, Valentina Tereshkova became the first woman to venture into space. Orbiting Earth 48 times over 3 days, she showed that women had just as much right to explore the stars as men. The Soviets were on a roll, but the Americans had their sights set higher, literally. NASA's Apollo program aimed for the moon, and in 1969, they did it. Neil Armstrong and Buzz Aldrin stepped onto the lunar surface while millions of people watched on their TV screens. One small step for man, one giant leap for mankind. Those words became legendary. Landing on the moon was a massive win for humanity, showing what was possible when ambition met technology. But after the excitement of the moon landings, space exploration changed direction. The Soviets launched the first space station, Salyut 1, in 1971, creating a place where cosmonauts could live and work in space for longer periods. NASA followed with Skylab in 1973, where astronauts conducted experiments and adapted to life without gravity for weeks at a time. These missions laid the groundwork for future long-term projects, proving that humans could survive in space for months if necessary. In the 80s, NASA introduced the Space Shuttle, a reusable spacecraft that seemed like the next big thing. It could carry astronauts, satellites, and even massive pieces of equipment into orbit. The Space Shuttle program accomplished a lot, including the deployment of the Hubble Space Telescope and the construction of the International Space Station. But it wasn't all smooth sailing. The Challenger and Columbia disasters were stark reminders of the dangers of space travel. Even so, the program carried on, and the ISS became a symbol of international collaboration in space. The ISS, which came online in the early 2000s, is like a giant science lab floating above Earth. Astronauts from the US, Russia, Europe, Japan, and Canada have all lived and worked there, conducting research that benefits life back home and prepares us for deeper space exploration. The station's experiments in microgravity have led to breakthroughs in medicine, technology, and even agriculture. In recent years, private companies have stepped into the game, changing the face of space travel. SpaceX, founded by Elon Musk, made headlines with its Falcon rockets and Dragon spacecraft. In 2020, SpaceX's Crew Dragon became the first privately built ship to take astronauts to the ISS. This was a game changer, proving that space exploration wasn't just for governments anymore. Other companies like Blue Origin and Virgin Galactic started offering suborbital trips for private citizens. Sure, it's expensive, but the idea of space tourism is becoming less of a dream and more of a reality. Looking to the future, the moon is back in the spotlight. NASA's Artemis program plans to send humans there again, including the first woman, aiming for sustainable exploration. Meanwhile, Mars looms as the next big goal. Missions are being planned to send humans to the Red Planet within the next few decades. Private companies and international agencies are working on the technology to make it happen. Mars isn't just a dream anymore. It's a target. Space exploration has always been about pushing boundaries and finding solutions to tough problems. The technology developed for space missions has reshaped life on Earth. Satellites have revolutionized communication, weather prediction, and navigation. Research in space has improved medical treatments, given us new materials, and even changed how we understand human biology. Humanity's drive to explore space is unstoppable. From Sputnik to Mars, we've come a long way. But there's still so much left to discover. Each step forward opens up new possibilities, new challenges, and new horizons. And as we look to the stars, one thing is clear. This is just the beginning. Could the Hubble tension reveal a flaw in our understanding of the universe? Or is it evidence of something even more bizarre? Tell us your thoughts and remember to like and subscribe for more.